All right, number 4 says, which of the following is a right triangle? Remember, you can do that with your hands, with your fingers. An L makes a right triangle. So which one of these is a right triangle? Which one of them has a right angle? Yeah, there's only one. Number 5, how many lines of symmetry does a square have? So this is how many ways can it be folded evenly. Well, I could fold a square like this in half. That would work. I could fold it like this in half. That would also work. So there's 2. How else could I fold a square evenly? Yeah, I could fold it diagonally. That would work. That's 3. Could I also fold it this way? I could. So how many lines is that total? Number 6. Number 6 says, which of the following statements is true? Which of the following statements is true? Okay. You just have to look here and try to figure out which is greater, okay, and you're going to have to do some addition. All right, we've been working on those for a long time, so I'm going to let you guys do that one, okay? Number 7, if the time is 4 o'clock, okay, I drew it in for you, what is the measure of the angle that is formed by the minute and the hour hands? So this angle is kind of longer, right? It kind of looks like this. That's the angle we have, okay? So it's a greater angle, right? It's a bigger angle. So 4 is going to be way too small. 20 is going to be way too small. We know that. What do we remember about 180 degrees? Well, a full circle is 360 degrees, and a half circle is 180 degrees. Does that look like a half circle? No way. So it could only leave us with one answer. Number 8. Number 8. Which statement could be made about the kind of angles in these 3 polygons? There's an equal number of obtuse, acute, and right angles. Well, if I look here, I don't see a right angle in either one of these shapes. Remember, right angles look like this. I don't see that anywhere, so there's no way it could be letter A. Let's look at letter B. There are mostly acute angles. So acute are those smaller angles, right? I see 1, 2, 3, 4 right angles here. So they're definitely not mostly acute, okay? And then let's look at C and D. There's an equal number of acute and right angles. Well, we just said these 2 shapes don't have any right angles, so there's no way that could be right. There is more obtuse angles than right angles. I would agree with that. This is the only shape with right angles, which means there must be more obtuse than right. Let's look at these 3. 9, 10, and 11. Okay. So 9 says, which 2 streets are perpendicular? So remember, perpendicular is like this. Okay, that's what perpendicular is. So which ones cross? Okay, Willow Way and Rolling Hills Lanes. Here's Willow Way, and here's Rolling Hills Lanes. Okay, are those like crossing like this? No, I mean I see an angle there, but it's definitely not perpendicular. Okay, let's look at B. Dandelion Drive right here and Rolling Hills Lane. Well, here's Dandelion Drive, and here's Rolling Hills Lane. Those are parallel to each other. They run side by side, not perpendicular. Let's look at letter C. Letter C. Breezy Boulevard, right here, and Aisha Creek. Do those make that shape? I don't think so. Foggy Meadow Road, right here, Foggy Meadow Road, and Rolling Hills Lane. If we kept going on Foggy Meadow Road, if we kept going like this, straight on Foggy Meadow Road, and this is Rolling Hills Lane, does that make that? Sure does. That would be the one that's perpendicular. Number 10. Which figure is an acute isosceles triangle? So which figure is an acute isosceles triangle? Well, we know we can eliminate letter A because letter A is a right triangle. So that's neither acute isosceles. That is neither acute or isosceles, so we can get rid of that. Letter B, all sides are equal to each other. So that would be an equilateral triangle. So we know that's not an option. Acute isosceles. Remember, acute is a smaller. What do you think about letter C? Okay, that looks like a little bit bigger. I don't think so. I think our only option is letter D. Let's look at number 11. Colton is finding the product of 62 and 50. Which expression could he use? So that is breaking this up. So I would have 60 and 2, and I would have 50. So which one of those would work? If I put this into a box method, I would have 62, and I would have 5 tens, which is 50. Okay, I have 0 ones and 50. So I know I would do 60 times 50. So if I don't see something that's 60 times 50, like do I see a 60 times 50 here? No, that's not an option. Do I see a 60 times 50? No, that's not an option. So now I'm with A or B. I would also have, so I would have 60 times 50. What else would I have? I would have 50 times 2. So you'll have to figure out which one of these shows 60 times 50 and 50 times 2.